Alekz Beads with DC Circuit Analysis, presented by Mantim Lee. Date January 2023. Introduction. My name is Mantim Lee. I am 70 years old living in Singapore. I am a retired engineer experienced in electromechanical repair and maintenance of steam sterilization equipment in hospitals. I wish to share with the knowledge seekers that I did a DC circuit analysis on the Alekz Beads Circuit to add on to the knowledge, to extend my understanding of how to use the circuit in DC direct current applications. The Alekz Beads were presented by Mr. Keshe in 68th Knowledge Seekers Workshop. Video source: 68 Knowledge Seekers Workshop, Day 1, July 2nd, 2015 p.m. YouTube. I may understand the Alekz Beads as each bead is a battery in the DC context, and as an inductor in parallel with a capacitor in the AC context. When there is no external DC input Vi power supply, each bead is a battery. When there is DC power supply in the circuit, each bead is a parallel combination, become a capacitor. The coil part is magnetical, sensitive to magnetic induction, which develops into voltage, V equal to minus L dV dt, equal to minus L times A dB dt. The rate of change of magnetic field B turns into voltage. B is the magnetic field in Weber per meter square, or Tesla. The straight wire part is gravitational, sensitive to receiving current. Q equal to C times V. I equal to dV dt, equal to C times dV dt. The rate change of voltage turns into current. C is the capacitance in farad. Modeling the Alekz bead. The Keshe plasma battery is a capacitor and inductor sandwiched with nano-coated aluminum oxide, gray color foil, brushed with copper oxide GaNs paste, then folded in fireproof baking paper. Area of the aluminum oxide foil equal to 50 mm times 150 mm equal to 0.0075 meters square. Thickness of the plastic shield equal to radius from the negative wire to the aluminum oxide copper oxide GaN insulator equal to 3 mm equal to 0.003 meter. Aluminum can foil may turn into aluminum oxide nanocoating with hydrogen peroxide. 2Al plus 3H2O2 into Al2O3 plus 3H2O. Capacitance. The capacitance of the capacitor is given by a parallel plate capacitor formula. C equal to A times epsilon naught times epsilon R divided by T. A equal to 50 mm times 150 mm equal to 0.0075 meters square. Epsilon naught equal to 8.85 times 10 to the power minus 12 farads per meter square. T equal to 1 mm GaNs plus 3 mm shield equal to 4 mm equal to 0.004 meter. C is equal to 8.85 times 10 to the power minus 12 farad per meter square times 0.0075 divided by 0.004 equal to 16 picofarad. Inductance L equal to mu naught N square divided by H times pi R square. N equal to 18 turns. R equal to diameter divided by 2 equal to 2 mm equal to 0.002 meter. H equal to 18 times 1.5 times 2 equal to 54 mm equal to 0.054 meter. Mu naught equal to 4 pi times 10 to the power minus 7 Henry per meter. L equal to 4 pi times 10 to the power minus 7 Henry per meter times 18 square times pi times 0.02 square divided by 0.054 equal to 0.09475 mu Henry. McGrath basic setups MGBS magnetic, MGBS gravitational. From this calculation, we may modify the Alekz bead as a combined inductor and capacitor in parallel, as shown in this picture. The red dot is the beginning of the magnetical coil, sense current. The straight wire is gravitational, receives current. The magnetical coil does not have an electrode attached to the capacitor, yet it can function by an external 50 Hz AC magnetic induction. Between the aluminum foil and the cable insulator is the dielectric of the capacitance. The Armand's connector may be used for interconnection between the Alekz beads. PTS-NPN. The plasma termination setup, PTS-NPN. Each bead may be modeled as an inductor in series with a capacitor. The red dot is the beginning of the coil, where the current enters. There is no connection from the capacitor to the magnetic electrode. The capacitor functions by electrostatic induction. The DC current has momentary or no effect on the inductance. The external 50 Hz induction develops a voltage between the electrodes, resulting as a DC battery. The capacitor separates the positive anode electricity and the negative cathode electricity. The end of the MGBSM is basically the same wire as the positive electrode, except it may carry a voltage drop due to the series connection of the 17 beads, 17 times 0.29 volt equal to 4.93 volt DC. For this reason, I prefer to have the PTS-NPN to be two capacitors connected head-to-head and without the bypass wire at C to avoid short circuit to the power supply VI. Under a 50 Hz induction, the plasma capacitor without GaNs gives 0.106 volt DC. Under a 50 Hz induction, the plasma capacitor with GaNs gives 0.29 volt DC. In a sample of plasma capacitor that I made, the induced voltage was 0.29 volt DC under a 50 Hz induction near to a McGrath home power unit. Connecting capacitors in series as shown in the MGBS-M outer ring as the McGrath basic setup magnetical. 17 pieces shall amount to 17 times 0.29 equal to 4.93 volt DC. The MGBS-G, the inner ring, as McGrath basic setup gravitational. 8 bits shall amount to 0.29 equal to 2.32 volt DC. I shall use these voltages value for the DC circuit analysis. In direct current DC circuits, the current flow has not frequency. It shall not create inductance to the Alekz bead. The external magnetic field B that carries the 50 Hz induction develops into voltage 0.29 volt DC. The frequency induced a back EMF in the inductance and showed as a battery voltage 0.29 volt DC, which impedes the direct current flow. As a result, the inductance component in MGBS-M is a battery added on voltage drop to the DC current. The capacitance shall act as a storage device for the DC electricity and may be modeled as a battery with an internal resistance R. The 50 Hz induction is to take effect first, producing voltage 0.29 volt DC each before the circuit may be switched on, or the bit would be like a wire short circuit to the input DC supply Vi. The Alekz Beads Circuit, no power supply, Vi equal to open. Without input Vi DC power supply, each Alekz bead shall serve as a battery. After a topological transformation, the Alekz Beads circuit reduced to a few batteries connected to a resistor low RL. My question is to find the current available to RL the low. I2 equal to how much? First, I set the battery to have an internal resistance R. Then apply the Kirchhoff law on each circuit loop. We have these notations: clockwise with current flow as positive, counterclockwise against current flow as negative. I1R plus I1 minus I2 times 17R minus 17B plus I1R minus B equal to B. This will transpose into 19R I1 minus 17R I2 equal to 17B. Loop 2. I2 minus I1 times 17R plus I2 times RL equal to 17B. That is 17R plus R2 bracket I2 minus 17R times I1 equal to 17B. Loop 3. I3R plus I3R plus 4B equal to minus 4B. Solving simultaneous equations 1 and 2. 17 times equation 1 equal to 323R times RI1 minus 289R times I2 equal to 289B. 19 times equation 1. 323R plus 19RL times I2 minus 323R I1 equal to 323B. Then equation 5 plus 4. We have 34R plus 19RL times I2 equal to 612B. That is I2 equal to 612B divided by 34R plus 19RL. No power supply Vi equal to 0 volt. Open circuit. Continue from previous slide. I2 equal to 612B divided by 34R plus 19RL. With Vi equal to 0, we want to find out whether RL can support a LED light. To light up an LED, we need 17B equal to 17 times 0.29 equal to 4.93 volt DC. The diode current ID equal to 4.93 minus 0.6 divided by 470 equal to 0.0092 ampere equal to 9.2 milliampere. RL equal to 470 ohm because 5 minus 0.6 divided by 470 ohm equal to 9.4 milliamp is within the LED light rating of 10 milliampere. 0.6 volt is the voltage drop in the LED. The load resistor RL in series with the LED is to shunt the current for the LED to operate. For an ideal battery, its internal resistance R is 0. We may arbitrarily set R equal to 1 ohm to account for its role in the circuit. B equal to 0.29 V DC. Then I2 equal to 612 times 0.29 divided by 34 plus 19 times 470 equal to 177.48 divided by 34 plus 8,930 equal to 177.48 divided by 8,964 equal to 0.0198 ampere equal to 19.8 milliampere. This current confirms it can light up an LED at the low point RL. This calculation indicated that without power supply Vi equal to 0, the Alekz Beads circuit can light up an LED, and its output power I square R equal to 19.8 times 10 to the power minus 3 square times 470 equal to 0.188 watt. With input Vi equal to 5 volt DC, my next question is, what if I put a power supply Vi equal to 5 volt to the circuit? Find I2 equal to how many? The answer may be Vi equal to 5 volt shall override the voltage at B equal to 0.29 volt to become 5 minus 0.29 volt DC. The Xc shall be clamped to 4.71 volt and become an energy storage device. Energy equal to half CV squared. Once again, we apply the Kirchhoff's law on the loops. Loop 1, I1R plus I1 minus I2 times 17R minus 17B plus I1R minus B equal to 5 minus B. That is 19R I1 minus 17R I2 equal to 5 plus 17B. Loop 2, 17R times I2 minus I1 plus I2RL equal to 17B. That is 17R plus R2L times I2 minus 17R I1 equal to 17B. I3R plus I3R minus 4B equal to minus 4B. Loop 4, I minus I1 minus I2 minus I1 plus I2 plus minus I3 plus I3 equal to 0. Solving simultaneous equations 1 and 2. 17 times equation 1, 323R times R times I1 minus 289R times I2 equal to 85 plus 298B. 19 times equation 2, 323R plus 19RL times I2 minus 323R times I1 equal to 323B. Adding the two equations together, 34R plus 19RL times I2 equal to 85 plus 612B. That is I2 equal to 85 plus 612B divided by 34R plus 19RL. As in previous slide 10, we may set R equal to 1 ohm, RL equal to 470 ohm, LED light with RL. I2 equal to 85 plus 612 times 0.29 divided by 34 plus 19 times 470 equal to 85 plus 177.48 divided by 34 plus 8,930 equal to 262.48 divided by 864 equal to 0.0293 ampere equal to 29.3 milliampere. The output power I square RL equal to 29.3 times 10 to the power 3 square times 470 equal to 0.4035 watt. Certainly, this is higher than without the power supply, 0.188 watt. Short circuit response. Ri equal to 5 volt DC. From previous line, I2 equal to 85 plus 612B divided by 34R plus 19RL. When the load is on short circuit, R equal to 1 ohm, RL equal to 0 ohm. I2 equal to 262.48 divided by 34 equal to 7.72 ampere. This calculation indicated that a 7 ampere fuse shall be required for circuit protection. Open circuit response, Ri equal to 5 volt DC. When the load is on open circuit, R equal to 1 ohm, RL equal to infinite ohm, I2 equal to 0. The current through the MGBS magnetic 17 bits is I1 minus I2. 19R times I1 minus 17R times I2 equal to 5 plus 17B from previous slide 11. 19 I1 equal to 5 plus 17 times 0.29. That is I1 equal to 9.93 divided by 19 equal to 0.5226 ampere. The voltage drop across 17B equal to I1 minus I2 times 17R equal to 0.5226 minus 0 times 17 times 1 equal to 8.8842 volt. This calculation indicated that the open circuit voltage shall be too high for 5 volt DC application. The number of 17 bits shall need to reduce to 7 bits. Then it may be manageable for mobile phone charging. Loop 1. I1 times R plus I1 minus I2 times 7R minus 7B plus I1R minus B equal to 5 minus 7B. That is 9R I1 minus 7R I2 equal to 5 plus 7B. When I2 equal to 0, I1 equal to 5 plus 7B divided by 9R equal to 5 plus 2.03 divided by 9 equal to 0.7811 ampere. Voltage drop across 7B equal to I1 minus I2 times 7R equal to 0.7811 times 7 equal to 5.46 volt. This voltage shall be workable to charge a mobile phone. Efficiency with LED lighting. With Vi equal to 5 volt DC, output equal to 0.4035 watt. Without Vi, output equal to 0.188 watt. This indicated that the 5 volt input is contributing 0.4035 minus 0.188 equal to 0.2155 net. And the Alekz Beads circuit is supporting 0.205 watt. Efficiency equal to output with Vi divided by input net equal to 0.4035 divided by 0.2155 times 100% equal to 187.24%. It may not be efficient to charge up a phone, as we shall see, to include power supply to reactor. 12 volt times 0.27 ampere equal to 3.24 watt. Energy storage. With Vi equal to 5 volt, the Alekz Beads shall become an energy storage device, half CV squared. The current flow with the battery is expanding energy, minus negative, whereas the current flowing against the battery is energy storage, plus. C equal to 16 pF, calculated in slide 4. Current I1 minus half 16 times 10 to the power minus 12 times 5 squared equal to minus 200 picowatt. I1 minus I2 plus half 16 divided by 17 times 10 to the power minus 12 times 5 squared equal to plus 11.765 picowatt. I1 equal to 0.5491 ampere is greater than I2 equal to 0.093 ampere, that is energy storage. Minus I1 is plus half 16 times 10 to the power 6 times 5 squared equal to plus 200 picowatt. I3 is plus 2 times half times 16 divided by 4 times 10 to the power minus 6 times 5 squared equal to plus 100 picowatt. Total equal to minus 200 plus 11.765 plus 200 plus 100 equal to 110.765 picowatt is storage in microwatt because the small capacitance. Application on mobile phone. To charge a mobile phone, we need Vi equal to 5 volt, I2 equal to 100 milliampere, equal to 0.1 ampere, RL equal to 5 divided by 0.1, equal to 50 ohm. And we change the 17 bits to 7 bits in the outer ring. From previous slide, 9R times I1 minus 7R times I2 equal to 5 plus 7B, using 7 bits for the MGBS magnetic. I2 equal to 100 milliampere equal to 0.1 ampere. Substitute I2 into equation 1. 9R times I1 minus 7R times 0.1 equal to 5 plus 7 times 0.29. 9 times I1 minus 0.7 equal to 7.03. That is, I1 equal to 7.03 plus 0.7 divided by 9 equal to 0.8589 ampere. Voltage across 7B equal to I1 minus I2 times 7R equal to 0.8598 minus 0.1 times 7 equal to 5.3123 volt. This mobile phone charging in working condition. Efficiency. Output I square RL equal to 0.1 square times 50 equal to 0.5 watt. Output without input equal to 0.188 watt. Efficiency with and without input equal to 0.5 watt divided by 0.188 watt equal to 2.6596 equal to 265.96%. It may not be efficient to include the power input to the plasma reactor equal to 12 watt DC times 0.27 ampere equal to 3.24 watt. Another way is to use the McGrath home power unit to run an electric fan 36 watt at 240 volt AC, 0.15 ampere, to generate that 50 Hz induction to support the Alekz Beads circuit while to enjoy the fan as a consumption. Next question, Vi equal to 12 volt DC. My next question is, what if the input power supply Vi equal to 12 volt DC? I2 equal to how many? I1, 19R times I1 minus 12R times I2 equal to 12 plus 17B, modified from slide number 9, equation 1. I2 minus I1, 17R plus RL times I2 minus 17R times I1 equal to 17B from slide 9, equation 2. Solving simultaneous equations 1 and 2. 17 times equation 1. 323 times R times I1 minus 289 R times I2 equal to 204 plus 289B. 19 times equation 2. 323R plus 19RL times I2 minus 323R times I1 equal to 323B. Two equations added together are 34R plus 19RL times I2 equal to 204 plus 612B. That is, I2 equal to 204 plus 612B divided by 34R plus 19RL. For Vi equal to 12 volt DC, I set R equal to 1 ohm, RL equal to 0.75 ohm, because 192 watt LED head and tail lights. See the next slide. Then I2 equal to 204 plus 612 times 0.29 divided by 34 plus 19 times 0.75 equal to 204 plus 177.48 divided by 34 plus 14.25 equal to 381.48 divided by 48.25 equal to 7.9063 ampere with 12 volt DC. Output I square RL equal to 7.9063 square times 0.75 equal to 46.8822 watt with Vi equal to 12 volt DC. From slide 9, I2 equal to 612B divided by 34R plus 19RL equal to 612 times 0.29 divided by 34 plus 19 times 0.75 equal to 177.48 divided by 48.25 equal to 3.6783 ampere without 12-volt DC. The output power without Vi is I2 square RL equal to 3.6783 square times 0.75 equal to 10.15 watt net. Net input equal to 46.8822 minus 10.15 equal to 36.73 watt. Efficiency equal to output divided by net input equal to 46.8822 watt divided by 36.73 watt equal to 1.2764 or 127.64%. Open circuit response with Vi equal to 12 volt DC. When the load is open, RL equal to infinity ohm, I2 equal to 0 ampere. The voltage across 17B equal to 17 times 0.29 equal to 4.93 volt DC by 50 Hz induction. I1 19R times I1 minus 17R times I2 equal to 12 plus 17B modified from slide 9, equation 1. Substitute I2 equal to 0, then I1 equal to 12 plus 4.93 divided by 19 times 1 equal to 16.93 divided by 19 equal to 1.12238. Voltage across 17R equal to I1 minus I2 times 17R equal to 1.1223 minus 0 times 17 equal to 19.1 volt DC. This calculation indicated that the open circuit voltage at the low end is sufficient to feed the 12-volt car battery, which supports to charge up a car battery with charging current 1.1223 ampere when there is 50 Hz induction. Short circuit response with Vi equal to 12 volt DC. When the load is short circuit, RL equal to 0 ohm, I2 equal to how many? I2 equal to 204 plus 612B divided by 34R plus 19RL with 12 volt DC equal to 204 plus 612 times 0.29 divided by 34 plus 0 equal to 11.22 ampere. This calculation indicated that a fuse of 10 ampere is to be installed for circuit protection. Application in cars. For Vi equal to 12 volt DC, this power supply may be obtained from a car battery. In car application, the 12 volt DC battery shall be used for ignition and mostly for head and tail lights. On the internet, I found maximum power drawn was 46.6 watt per LED light headlights. Source: brightest and best LED headlights review. 5 top LED headlight bulbs. YouTube by Aura Lighting of Automobile. For 2 headlights and 2 tail lights maximum power drawn may be 46.6 times 4 equal to 186.4 watt, round off to 192 watts, so that current I equal to 192 watt divided by 12 volt equal to 16 ampere. That is, RL equal to 12 volt divided by 16 ampere equal to 0.75 ohm. This corresponds to RL equal to 0.75 ohm as in previous slide 14. The plasma reactor. Coming back to the Keshe blueprint, I see there is a ping pong ball style plasma reactor which could be used using 12 volt DC based on a computer fan motor. The rotation of this plasma reactor shall replace a McGrath home power unit to provide the 50 Hz McGrath field induction to the Alekz Beads. This in 12 volt DC for the reactor computer fan motor is for the 12 volt DC car battery from the cigarette lighter. In the next slide, we shall analyze the mechanics of the plasma reactor. Of radius 20 mm equal to 0.02 meter. Volume 4/3 pi r cubed equal to 4/3 times 3.1416 times 0.02 cube equal to 40 ml equal to 40 gram. Density of water 1 gram per milliliter. Avogadro's number 6.02 times 10 to the power 23rd molecules per mole. Oxygen has atomic number 8, E electronic configuration 26. Copper has atomic number 29, configuration 2,8,18,1. Copper oxide CuO has 5 electrons per molecules, has 3 electrons. Copper 2 oxide Cu2O 4 electrons per molecule, 3 electrons. Elementary charge equal to 1.6021 times 10 to the power minus 19 coulomb per electron. The blueprint reactor contains carbon dioxide liquid gas, nanophosphorus P, and dry gas of copper oxide CuO, copper 2 oxide Cu2O, loaded means to me as active. The small trace of phosphorus shall react with water to form chemiluminescence materials. 4P plus 4H2O into 2HPO plus P2O2 plus 6 hydrogen. Ping pong ball plasma reactor. For analysis, let me set the following proportions. Water 4 ml equal to 4 gram. 4E 3 electrons per mole. Phosphorus P equal to 4 grams. HPO 5 electrons. H2O2 16 electrons. Carbon dioxide liquid gas equal to 4 grams. 8 electrons, 3 electrons per mole. CuO dry gas equal to 14 grams, 5 electrons. Cu2O dry gas equal to 14 grams, 4 electrons, 3 electrons per mole. Total weight equal to 40 grams. The ping pong ball contains 40 grams, calculated in slide 13. 4 grams is 10% volume. 14 grams is 35% volume. With the above data, we now calculate the number of free electrons available from each molecule to make electricity. Atomic weight per molecule, H2O, 2 times 1.008 plus 16 equal to 18.016. 1 gram of water equal to 6.2002 times 10 to the power 23rd divided by 18.016 equal to 0.3341 times 10 to the power 23rd molecules. HPO 1.008 times 1 plus 30.97 plus 16 equal to 46.978. 1 gram of HPO equal to 6.02 times 10 to the power 23rd divided by 47.978 equal to 0.1255 times 10 to the power 23rd molecules. P2O2 30.97 plus 16 times 2 equal to 93.94. 1 gram of P2O2 equal to 6.02 times 10 to the power 23rd divided by 93.94 equal to 0.0641 times 10 to the power 23rd molecules. Carbon dioxide 12.01 times 1 plus 16 times 2 equal to 44.01. 1 gram of carbon dioxide equal to 6.02 times 10 to the power 23rd divided by 44.01 equal to 0.1368 times 10 to the power 23rd molecules. Copper oxide 63.55 plus 16 equal to 79.55. 1 gram of CuO equal to 6.02 times 10 to the power 23rd divided by 79.55 equal to 0.0757 times 10 to the power 23rd molecules. Copper 2 oxides 63.55 times 2 plus 16 equal to 143.1. 1 gram of Cu2O equal to 6.2 times 10 to the power 23rd divided by 143.1 equal to 0.0421 times 10 to the power 23rd molecules. We now compute the number of free electrons available. H2O 4 grams, 4 electrons. 4 times 0.3341 times 10 to the power 23rd times 4 equal to 5.3456 times 10 to the power 23rd electrons. 2 HPO 2 grams, 5 electrons. 2 times 0.1255 times 10 to the power 23rd times 5 equal to 1.255 times 10 to the power 23rd electrons. 1 P2O2 1 gram, 16 electrons. 1 times 0.0641 times 10 to the power 23rd times 16 equal to 1.0256 times 10 to the power 23rd electrons. Carbon dioxide 4 gram, 8 electrons. 4 times 0.1368 times 10 to the power 23rd times 8 equal to 4.3776 times 10 to the power 23rd electrons. Copper oxide, 14 grams, 5 electrons. 14 times 0.0757 times 10 to the power 23rd times 5 equal to 5.2229 times 10 to the power 23rd electrons. Copper 2 oxide, 14 grams, 4 electrons. 14 times 0.0421 times 10 to the power 23rd times 4 equal to 2.3576 times 10 to the power 23rd. Total 19.6604 times 10 to the power 23rd electrons. Electronic charge is 1.6021 times 10 to the power minus 19 coulomb. Total electron charge available equal to 19.6604 times 1.6021 times 10 to the power 23 minus 19 coulomb equal to 31.4979 times 10 to the power 4 equal to 0.315 times 10 to the power 6 coulombs. Note, we accounted for 3 electrons on the outer shelf, the electrons that are not bounded by chemical bonds and not core electrons in the molecules. Reactor rotation. For 50 Hz induction, we need to spin the ping-pong ball reactor to 3000 RPM. It is because frequency equal to 50 Hz, 2 times pi f equal to omega radians per second. That is radian equal to 2 pi times 50 radians per second equal to 2 pi times 50 times 60 divided by 2 pi equal to 3000 RPM. The motor specifications is 3000 RPM at 12 volt DC. Reactor rotation. For 60 Hz induction, we need to spin the ping-pong ball reactor to 3600 RPM. It is because f equal to 60 Hz, 2 pi f equal to omega radian per second. Omega equal to 2 pi times 60 radian per second equal to 2 pi times 60 times 60 divided by 2 pi equal to 3600 revolution per minute. Motor specifications 3600 RPM at 12 volt DC. For 150 Hz induction, we need the reactor to rotate at 9000 RPM. I came across Mr. Keshe's video, Knowledge Seekers Workshop, indicated that the Foundation has proven plasma technology frequency at 150 Hz equal to 150 per second equal to 150 revolution per second equal to 9000 RPM. I include this for analysis as I do not know whether 9000 RPM was used in the 68 workshop video. DC circuit is not sensitive to frequency, yet the reactor speed gives induction, magnetic field strength H, units in ampere per meter, and the magnetic field B in Webers per meter square. 3000 RPM for 50 Hz, 3600 RPM for 60 Hz, 9,000 RPM for 150 Hz. Motor specifications: 12 volt DC. We now continue to analyze the mechanics of the ping-pong ball plasma reactor. Consider a sphere rotating about the z-axis, an infinitesimal cube with dimensions dx, dy, dz. Its mass would be rho dx times dy dz. At a distance r from the axis, the velocity of the cube v equal to omega r units in meter per second. Apparently, at different r's rotation about the z-axis, the cube would experience different velocity. To sum up this velocity variation, there is a physical quantity measurement called the moment of inertia shall be involved. Kinetic energy equal to 1/2 rho triple integral of omega r squared times dx dy dz equal to 1/2 rho omega squared double integral 2/3 pi r cubed equal to times dr dc dz equal to 1/2 rho omega squared integral from minus r to plus r 4/3 pi r4 dr d alpha equal to 1/2 rho squared pi 4 divided by 3 1/5 r fifth times 2r. Note: change parameters dy equal to dr times dphi, dc equal to dr times d alpha equal to 1/2 rho 4/3 r cubed times 2/5 r squared times omega squared equal to 1/2 m r squared omega squared, where m equal to rho times 4/3 pi r cubed equal to 40 grams, r squared equal to 2/5 r squared equal to radius of gyration, r squared equal to 2/5 times 0.02 squared equal to 0.0002 meters squared. In physics, we have moment of inertia I equal to mr squared, kinetic energy equal to 1/2 times I omega squared. When the gas contents are spin up to speed, the velocity at the radius of gyration shall represent the effective velocity of the spherical reactor rotating about the z-axis. For 50 Hz, total electron charge available equal to 0.314979 times 10 to the power 6 coulombs from slide 21. Q times F equal to 0.314979 times 10 to the power 6 coulomb times 50 per second equal to 15.749 times 10 to the power 6 ampere. This is 15.75 million amperes. This calculation indicated that a ping-pong ball-sized plasma reactor offers a possibility to release millions of amperage. Although these are free electrons, they are still bound in the molecules In neutral charge condition, we need to take some mechanical work to take out the current. We shall find out how many amperes may be obtained by spinning the ball. The reactor starts with materials in neutral charge. My next question is, how do we get the current by spinning the ball? There are two ionization processes that may be applicable. 1. Radioactive recombination. 2. Inelastic collision. Source: Physics of Electric Propulsion by Robert G. Jahn. Pages 29 to 32. ISBN 0-486-45040-6. Radioactive recombination. There is the process also known as chemiluminescence. Source: Wikipedia. The phosphorus reacts with water to form HPO and H2O2. Both oxides emit visible light. 4P plus 4H2O into product 2HPO plus P2O2 plus 6H2 plus Hν. H is the Planck's constant, nu is the frequency. Product A plus product B into products plus light. The chemiluminescence is through a process called radioactive recombination. A ion plus electron into product A plus Hν. HPO plus electrons into HPO plus Hν, and H2PO ion plus electron into P2O2 plus Hν. These lights are photons, Hν, that may collide with the free electrons in the reactor. With the help of mechanical inelastic collisions, there may be more release of electron charges, manifestation as a circular current flow, producing magnetic field around the reactor. In elastic collision, the CuO, Cu2O may collide with the luminescent phosphorus oxides. With sufficient high relative kinetic energy, the vulnerable molecules, electrons may be lost through a strong valency interaction with another molecule in the form of A plus B into A ion plus B ion and A plus B plus ion into A ion plus B. We shall now analyze whether the kinetic energy of the molecules are sufficient for the ionization in the next slide. From previous slide, rotational kinetic energy of the reactor at 3000 RPM for 50 Hz induction, Ke equal to half mR square omega square equal to 0.5 times 40 times 10 to the power minus 3 times 0.0002 times 3000 times 2 pi divided by 60 square equal to 0.0040 times 10 to the power minus 3 times 314.16 square equal to 0.3948 Newton meter. The free electrons are mainly located in the oxygen atoms as in P2O2, 8 of 14 electrons, CuO, 5 of 5, Cu2O, 4 of 4, H2O, 4 of 4, carbon dioxide, 10 of 12, HPO, 4 of 7 electrons. Understanding the ionization energy of oxygen shall answer the question of how to release those free electrons as current. In my previous video presentation, David Perry's Space Warp Drive Feasibility Studies, YouTube, I followed the Bohr's model of atoms and deduced a formula for atomic elements' orbital transition change of energy as delta E equal to c squared times 0.0024 times 10 to the power minus 15 times 1 over n1 squared minus 1 over n2 squared joules, where Z is the atomic number. For oxygen, Z is equal to 8. The outer shell electrons have to move from orbital 2 to orbital 3 to get ionized. Delta E equal to 8 squared times 0.024 times 10 to the power minus 15 times 1 over 4 minus 1 over 9 equal to 64 times 0.0024 times 10 to the power minus 15 times 0.25 minus 0.1111 equal to 0.0213 times 10 to the power minus 15 Newton meter. For 50 Hz, the energy ratio 0.3948 divided by 0.0213 times 10 to the power minus 15 equal to 18.5352 times 10 to the power 15 oxygen atoms. This calculation ratio greater than 1 indicated a possibility of ionization of the oxygen. Each oxygen has a minimum of 4 electrons, and so these may release electrons 18.5352 times 10 to the power 15 times 4 times 1.6021 times 10 to the power minus 19 Coulomb, equal to 118.781 times 10 to the power minus 4 Coulomb. Current equal to Q times F equal to 118.7810 times 10 to the power minus 4 times 50 equal to 0.5939 ampere for 3000 RPM. For 50 Hz, coming back to consider the magnetic induction to the Alekz beads, the reactor's effective current at the radius of gyration gives rise to the magnetic current strength H measured in ampere per meter. H equal to current divided by 2 pi radius of gyration. Taking the square root of 2 over 5 r squared equal to square root of 0.4 times 0.02 squared equal to 0.01265 meters. H equal to 0.5939 ampere divided by 2 pi times 0.01268 0.65 equal to 7.4721 ampere per meter, or B equal to mu naught times H. B equal to 4 pi times 10 to the power minus 7 times 7.4721 Weber per meter square, equal to 93.8974 times 10 to the power minus 7 Weber per meter square, equal to 9.4 mu meter Weber per meter square. For 60 Hz, Ke equal to half 40 times 10 to the power minus 3 times 0.002 times 3600 times 2 pi divided by 60 square, equal to 0.0040 times 10 to the power minus 3 times 376.992 square, equal to 0.5685 Newton meter. The energy ratio equal to 0.5685 divided by 0.0213 times 10 to the power minus 15, equal to 26.69 times 10 to the power 15 oxygen atoms, equal to 26.69 times 10 to the power 15 times 4 times 1.6021 times 10 to the power minus 19, equal to 171.0408 times 10 to the power minus 4. Current equal to QF equal to 171.0408 times 10 to the power minus 4 times 60, equal to 1.02862 ampere for 3600 RPM. H equal to current divided by 2 pi radius of gyration, equal to 1.0262 divided by 2 pi divided by 0.01265, equal to 12.911 ampere per meter. B equal to 4 pi times 10 to the power minus 7 times 12.911, equal to 16.22 mu Weber per meter square. For 150 Hz, Ke equal to half times 40 times 10 to the power minus 3 times 0.0002 times 9,000 times 2 pi divided by 60 square, equal to 0.0040 times 10 to the power minus 3 times 642.48 square, equal to 1.6511 Newton meter. Energy ratio 1.6511 divided by 0.0213 times 10 to the power minus 15, equal to 77.5164 times 10 to the power 15 times 4 times 1.6021 times 10 to the power 19, equal to 496 times 7561 times 10 to the power minus 4 times 150 per second, equal to 7.455 ampere for 9,000 RPM. H equal to 7.455 amp divided by 2 pi divided by 0.01265 meter, equal to 93.7943 ampere per meter. B equal to 4 pi times 10 to the power 7 times 93.7943 equal to 117.86 mil Weber per meter square. These calculations indicated that a 50 Hz plasma reactor releases 0.5939 ampere, would be equivalent to a McGrath home power unit operating 4 times 36-watt electric fans. Each fan may draw 0.15 ampere at 240 volt AC. Spinning the reactor to 3600 ampere has 16.22 divided by 9.4 equal to 1.7 times stronger magnetic field. Spinning the reactor to 9000 rpm has 117.86 divided by 9.4 equal to 12 times higher magnetic field. Application in cars, Vi equal to 12 volt DC. On the blueprint circuit, the plasma reactor is connected to V out as the load RL. The Alekz Beads circuit got its Vi equal to 12 volt DC power supply from the cigarette lighter outlet as in the connection to the PTS NPN, same as the input terminals of the circuit. A computer fan motor is the load shall take 0.27 ampere as in the picture. This indicated that RL equal to 12 volt divided by 0.278 equal to 44 ohms. By setting R equal to 1, RL equal to 44 ohms, we substitute back into I2. I2 equal to 612B divided by 34R plus 19RL, calculated in slide 9. I2 equal to 612 times 0.29 divided by 34 plus 19 times 44 equal to 0.2044 ampere without 12 volts. The output power without Vi, I square RL equal to 0.204 square times 44 equal to 1.83 watt. With Vi 12 volt DC, I2 equal to 204 plus 612 B divided by 34R plus 19RL equal to 206 plus 612 times 0.29 divided by 34 plus 19 times 44 equal to 381.48 divided by 870 equal to 0.4385 ampere. With 12 volt DC, the output power equal to I square RL equal to 0.4385 square times 44 equal to 8.4612 watt with 12 volt DC. The net input equal to 8.4612 minus 1.83 equal to 6.6312 watt. Efficiency equal to net divided by net input equal to 8.612 watt divided by 6.6312 watt equal to 1.2987 or 129.4 87%. This calculation indicated that 3000 RPM is sufficient to support the computer fan motor, which takes 0.27 ampere, versus the reactor available 0.5939 ampere. The short circuit current 381.148 divided by 34 equal to 11.21 ampere. So 10 ampere fuse required for circuit production. The plasma termination setup, PTS NPN, is a critical component in the circuit because it is to withstand the voltage stress, the 12-volt DC from the car battery. Before connecting the circuit to the 12-volt DC, please check that the looping magnetic wire, blue A from C, does not touch the gravity wire, red to B. Touching the wire shall give rise to short circuit, resulting in heating up of wires and fuse blown. In hand making the PTS NPN beads as plasma capacitors, the capacitance insulation must be good. Perhaps use a bit longer baking paper, fireproof, that is width 100 times length 210 mm to wrap the 50 times 120 mm aluminum foil brushed with mixed GaNs. Using thicker aluminum foil from empty cans to avoid voltage pinch through breakdown of insulation. See the final equivalent circuit with fuse below. Application in cars. In cars application, the Alekz Beads Circuit shall be placed with the plasma reactor as shown in the blueprint. The Vi equal to 12-volt DC power supply shall come from the cigarette lighter outlet, with the plasma reactor as the low RL. A 10 ampere fuse shall be required for circuit protection. Without fuse, it may short circuit to the car battery, blow the car's electrical system fuse. The blueprint indicated 15 ml of washed liquid carbon dioxide gas to be put in the car's fuel tank and filled up to quarter tank, that is 25% of full tank for use. The fuel is a hydrocarbon product containing carbon, hydrogen. The carbon dioxide gas in the plasma reactor shall link up with the carbon dioxide gas in the tank. Likewise, the carbon dioxide shall link up with the carbon in the fuel. The H2O in the reactor shall link up with the hydrogen in the fuel. As the fuel is consumed in driving, the reactor's plasma McGrath field shall meet the demand of the plasma energy, expecting to save energy for the vehicle. Conclusion 1. The Alekz Beads Circuit has a series of 25 pieces of plasma batteries arranged in concentric circles in the form of a planetary system. The outer circle has 17 pieces connected to the positive, beginning with coiled wire as magnetical, sensitive to magnetic induction. The inner circle has 8 pieces connected to the negative end with the straight wires, looping the plasma batteries in a closed loop, sensitive to receiving current. With 50 Hz induction, the 17 pieces can induce 4.93 volt DC at the low Vout without power input Vi equal to open. Conclusion 2. With 5 volt DC input at Vi from a mobile phone battery power bank and 50 Hz induction, the Alekz Beads circuit may be used to charge up a mobile phone to save energy. For this application, the outer ring MGBS magnetic shall need to change from 17 to 7 bits. Calculated efficiency at 203.27%. 7 ampere fuse to be installed for circuit protection. With 12 volt DC input at the Vi from a car battery, a 50 Hz induction, the Alekz Beads may be used for support of 192 watt LED head and tail lights to save energy. Calculated efficiency at 139.89%. 10 ampere fuse to be installed for circuit protection. Conclusion 4. With 12 volt DC at Vi from the cigarette lighter outlet, the Alekz Beads circuit may be connected to a 150 Hz induction, the ping pong ball size plasma reactor at the low Vout to rotate at 9,000 RPM. It may support the reactor to run to save electrical energy and extend to save fuel energy. 10 ampere fuse to be installed for circuit protection. Conclusion 5. The PTS NPN is a critical component subject to voltage stress V input Vi. Careful check to make sure that the capacitance, shields, insulations are intact. Magnetical coils wires do not touch the gravitational straight wires at termination B and A to avoid inadvertent short circuit to the power supply. Circuit review. Caution: as in all electrical project endeavors, caution in electrical wiring conductivity. Use the correct wire size for components and lead wires to avoid heating up of wires for appliances and devices. Tightening of termination screws and connectors to avoid sparking over and may render breakage of insulation and heating up of wires. When finished testing, the entire circuit with the plasma reactor is to be installed into a transparent plastic box for circuit fixation to allow the magnetic field to pass through without wave diffraction. The magnetic field B is traveling in speed of light. It is light. 12 volt DC label to be used to alert users and maintenance personnel. Thanks for watching. This completes my presentation based on DC circuit analysis and simulation. Thank you, Mr. Keshe, for the knowledge seekers public teachings. Thank you, Alekz Beads. Thank you, Armand. Thank you, Robert G. Jen. Thank you, Lighting Automotive. Thank you, Wikipedia. Thank you, Amazon. Thank you, YouTube. Thank you, knowledge seekers. Have a good day. Peace to the world.